you can use it in other emulator, and also MST is not one of the topics of the CCNA, but the STP and rapid STP are the topics of the CCNA. Switch spanning tree mode, rapid PVST also. If you want to monitor it, you can use again show spanning tree summary. So easy. Let me first to show you one example. After that, we can review some other topics, and also we will learn about the other differences about the STP and RSTP. Okay, this is our scenario. As you can see, in this scenario, by default, we are using the per VLAN STP. Let me to show you here in the switch 1, en conf t, host name is, for example, switch 1. You can use show spanning tree. Look at here. Show spanning tree can show us that we are using the PVST, because here you can see IEEE. Or if you want, you can use show spanning tree summary. Here we can see the switch is in PVST mode. So easy. And this is the root bridge, for example. And then in switch 2, for example, this is switch 2, en conf t, host name switch 2. And then let me to show you show spanning tree summary. Again, here we are working is in the PVST, and this is the switch 3. In switch 3, en conf t, host name switch 3, and then show spanning tree. Let me to show you here. Show spanning tree enabled protocol is IEEE. Show spanning tree summary can show us that the switch is in PVST mode. So easy. Also, let me to add one PC here. For example, this is our PC, and this PC, okay, connected to the port fast Ethernet 01 of the switch 2, and also, for example, we can add another PC. This PC, this is connected to the fast Ethernet 01 of the switch 3, and let me to assign one IP address to each of these switches, these PCs, 192.168.11/24 or 110/24. The IP of the PC2 and the IP of PC3 is 192.168.111. Okay, let me to assign these two IP address first to the PC2 here. In the IP configuration, 192.168.110, mask is 255.255.255.0, and then to the PC3, the IP address is 192.168.111, 255.255.255.0. That's it. Now we can send traffic from the PC2 to PC3, ping 192.168.111. We have connectivity. Very good. Look at here. I'm going first to show you that what is happening in the STP. You have experienced this, but I'm going to review the, for example, outage of the link here. From the PC1, from the PC2 to PC3, I'm going to send traffic. Look at here, ping 192.168.111. You know that this ping now is going from this path to this ICMP echo, from this path to the switch 1, then switch 2, switch 3, and then PC3. Let me to create one, for example, direct topology change. This I'm going to remove this link, but first here in the ping, I'm going to use ping 192.168.111-t. Okay, and now I'm going to remove this link. Look at here, 1, 2, 3. Okay, this interface maybe take 30 seconds to be coming up. Because of that, for 30 seconds, the connectivity between the PC2 and PC3 is, for example, cannot be established, and we need to wait 30 seconds. After 30 seconds, we will have connectivity. And this is the slower convergence time of the STP in compare with the RSTP. In RSTP, after only 1 or maybe 2 seconds, the connectivity again will be established. Look at here now, we expect to see the ICMP echo reply from the PC3, okay, because the connection now is changed to the green. Look at here, after some second, maybe we see to have connectivity. Look at here. We need, yes, now we have connectivity, maybe more than 30 seconds, because this is packet tracer, it's not important. Look at here again, I'm going to add this link Look at here. When you are adding this gigabit 01 to the gigabit 01 of the, for example, gigabit 02 of the switch 1 to gigabit 01 of the switch 3, you will see that again this ping is, for example, tearing down. Look at here. After some second. Why? Because first this interface is blocked, and then this interface goes to the listening and learning state. Again, we need to wait 30 seconds. This is the spanning tree protocol, traditional spanning tree. Now let me to convert the mode of the switch to the RSTP. First, starting from the switch 1, conf t, spanning tree mode. Look at here, we have 2 options in packet tracer, but actually we have 3 options: PVST, rapid PVST, and MST. But here I'm going to use only rapid PVST. That's it. And then this is the switch 1, and in switch 2, let me to show you spanning tree, conf t, spanning tree mode, rapid PVST, and then finally in the last switch I'm going to configure conf t, spanning tree mode, rapid PVST. Don't forget, you need to configure the H ports with the spanning tree port fast. In the, for example, here in the switch 2, we need to configure interface faster than a 01 with the spanning tree. For example, port fast, spanning tree, port fast, so easy. Also in the switch 1, in switch 3, we should do the same command: interface fast than 01, spanning tree, port fast. This is the H port in the rapid PVST. So easy. Okay, now all of these switches are working in the rapid PVST mode. Let me to show you, for example, from the switch 1, about the root bridge, root port, and designated port, we don't have any difference. Okay, here in the switch 1, I'm going to show you show spanning tree summary. You can see that here now the switch is in rapid PVST mode, and also show a spanning tree. It can show us that this switch is working with RSTP. But about the other things, for example, this bridge is the root and the role of the ports, everything is same. Here you can see 2 difference. The first is the key of the keyword of the RSTP, and in show a spanning tree summary also you saw the rapid PVST. Let me to show you the switch 2. This is switch 2, show a spanning tree. Okay, can show us that here we have the fast Ethernet 01 as designated port, gigabit 02 designated port, gigabit 01 root port, such as the STP, but this is RSTP. Don't forget that in real device, I will show you in the for example, front of the H port. Okay, for example, here on front of this line, okay, you have the a key, we call it the H port. Okay, here you will see the H. I will show you in other emulator, but here we can see the H. Okay, very good. After that, in switch 3, we have the same condition. Look at here, this is the switch 3. Show a spanning tree summary can show us this switch is working in rapid PVST mode, and show a spanning tree summary can show us that, or show a spanning tree can show us that everything is same with the, for example, STP traditional. Okay, the port 2 is block, is alternate, has alternate role, and the state is block. So easy. Okay. Now let me to try to send traffic from the PC2 to PC3 again. As you can see, we are sending traffic now, and after some second I'm going to block or remove the interface between the switch 1 and switch 3. Look at here. After removing, you can see that after only maybe less than 1 second, this interface changed to green. And as you can see, only we are experiencing 1 timeout, or maybe less than 1 timeout. So interesting. Look at here. Again, I'm going to add another link here. Gigabit 02 to gigabit 01. Look at here. Again, after some second, this interface now will change to green without any, or maybe only 1 request timeout. So interesting. Because of that, it's recommended to using the RSTP in the real networks. Let me to show you the same feature with the other emulator, because I'm going to practicing more than this about the RSTP. Look at here, this is the EVE-NG emulator. Okay, this is the same scenario. Switch 1, conf t, host name. Okay, host name, then for example, switch 1, And then we need to convert the mode to rapid PVST, spanning tree mode rapid PVST. That's it. And this is switch 2 conf t host name switch 2, then spanning tree. Okay, mode, look at here. Here we have three modes: MST, PVST, and rapid PVST. Let me use the rapid PVST.